Okay, so we're going to do a quick tutorial on exercise 17.12, part A. This is the edited problem that the professor posted. So, very briefly, a tall skyscraper has an official height of h naught. Assume that this height was measured on a cool day when the temperature was t naught. Suppose you measure it again in a hot summer day and discover that is h taller. H is much smaller than h naught. What is the expression for the temperature T, assuming that the building is in thermal equilibrium with the air and that its entire frame is made of steel, steel? Do not use a numerical value. So this was the homework problem that a lot of people said they had a hard time with. It's a conceptual problem. And again, it's a problem where you don't have numbers to deal with. You need to solve for a final equation. And how we're going to do that is using equation, let's see, which equation is this? This is equation 17.6. So chapter 17, section 6 of the textbook states that thermal expansion and thermal stress. So thermal expansion is going to be delta L equals alpha length, delta L is length. So the change in length, this is alpha. This is horrible. Let me just erase this real quick and make a better alpha. I'll do like a, oh, that's just as bad. Alright. I cannot draw an alpha. I'll do this. Alpha. Yeah, that looks pretty bad still, but for the sake of this, alpha, length 0, delta t. Delta t. Alright, that's the equation we're working with, is the change in the length equals the alpha, which is a coefficient. It's just something that's going to be given to you if you're going to work with numbers. Length naught and delta t. So let's see. That delta L, that change in length, is going to be this. It's going to be our h. And discover that is h taller. So that's going to be, you know, if we had a max length, it would be h naught plus h, which is the change in h. So that's going to be this. Then we have length initial. So the initial length is actually going to be right here. That's going to be this. And that just leaves this, which is this alpha. This alpha is really just going to be our alpha steel. And then that just leaves this business right here. And you're probably wondering what to do with this. Well, this is what we're solving for, except not in this way. So let me just write the formula the way it's going to be expressed as an answer. So this is going to be h, and this is going to be alpha steel. This is going to be h naught. And then this delta L, whoa, stroke eraser, h, capital H naught. And this delta t is going to be t minus t naught. So we're going to have, I'll put that in blue. We're going to have t minus t naught. Because remember, all that is dt. That's just the change in temperature. And it's asking for the final temperature. So this is what it's asking for right here. So this is going to be this. that looks like a mess, but it makes sense. And we're just going to be solving for this basically, and that's it. It's pretty simple. We just have to get used to thinking with letters and not just plugging in numbers. But in reality, to get this, you would have to, pretty much isolate and do all this. It's the same exact steps with numbers. It's just that you don't think of it that way. So, like right off the bat, we're going to just divide by alpha steal H naught. So this is going to be alpha steal. God, that is horrible. I'm just going to put an A. It's hard to draw with this thing. I'm just gonna put an A. I'm just gonna put like a A. So this is alpha steal H naught. So we're just gonna divide by alpha steal H naught, and we're gonna get H over alpha steal big H naught, and that's going to equal to T minus T naught, and then from here we just add T naught. So we add T naught, and these will cancel. So we get H over alpha steal H naught, all of this business, plus T naught, and that's going to equal to T. And this is the answer right here. This is the final answer right here.